Okay, guys, from 2 science, guys, worksheet number 15. This one we do it a bit differently. I gave you the worksheet first, ask you to try first, then give me back the answers. Okay. Purpose of giving back an answer, this is not a test. This is to make sure you've done some work. You know, this chapter here is the basics for one of the basic chapters for physics, and this chapter you will carry forward for next year as well. So if you problem with these chapters here, like some chapters maybe you just learn that for that year, that's all. Bungkus and ikat tepi and then keep that. So there's no continuation. But this is an important chapter where there's a lot of continuation for next year as well. Okay, so don't take it too lightly. Okay, only a few of you only send back the answers. Okay, send back the answers. The rest of you, I hope you will do the work first before you check out these answers in this worksheet here, and also the video as well. Right? Yeah. Don't take it too easy, guys. Okay, you still got a few more chapters to go. Okay, form 2 you still got a few more chapters, few heavy chapters to finish up. Okay, let's go through this, guys. Question number 1 from this force and movement. Identify the force shown by the arrows that act on the two types of vehicle. Okay, so a plane that is flying, what is the force acting on it there? What is keeping it there grounded there? Has to overcome this force there will be gravitational force. Okay, so the thrust of the engine there enables it to fly, overcome the gravitational force that is keeping down. So down here this will be gravitational force. Then what keeps a boat upwards? So anything to do with fluids there, the type of force here, this one will be buoyancy force there. Okay, so if the boat can displace the water, can make the water displace the water, it can stay afloat. When it fails to displace the water too heavy upper, then the boat will start to sink. Okay, yeah. Number 2, diagram shows, and the diagram above, draw and label magnitude of force and direction of force. Okay, so this one, this lady here, she's pulling this back. Okay, this trolley back here, pulling this trolley back here. Alright, pulling this trolley back is working. Okay, so the direction of force, is this way. This is the direction of force. Then another thing they ask here is the magnitude of force. Okay, so magnitude of force is this way, guys. Okay, she's holding, she's pulling, so the magnitude of force is towards the back, towards the trolley back. Okay, so this is the magnitude of force, and this is the direction of force. So you must label in the diagram itself. Okay, yeah. Then question number 2, a force is a pull or a push. It's a pull or a push. So this is a pull. Then state the SI unit for force. Force, the SI unit will be Newton. Symbol will be N. Okay, state the SI unit will be Newton. Symbol will be N. Give one example of force: gravitational force, frictional force, buoyancy force, all this force. All that boleh pakai. Okay, that one shouldn't be a problem. Straightforward example. Okay, this is a good question. Next one. C. Diagram below shows John and Kamal who are fighting over a toy car. Based on the diagram, predict what will happen if John and Kamal apply the same force. Car there, both applying the same force. Logically, magnitude of force, that means it's the same. Same force, magnitude of force, same. One side tak ada banyak, one side tak ada kurang. So what will happen is the toy car will not budge, will not change. It means won't go to both sides lah. So both same, betul-betul, katakan tepat-tepat. Okay, maybe the few seconds there, they were applying the same force, means the toy car will not budge from its place because the magnitude of force is equal. Okay, so the toy car remains there, does not budge, does not move because the magnitude of force is equal. Okay, Kamal applies a bigger force than John. Now Kamal angry already. Kamal applies a bigger force than John. The toy car logically will go to Kamal. Okay, the toy car goes to Kamal. The magnitude of force from Kamal is higher. That means Kamal has got more magnitude, more force applied there. Thus the direction of force will go towards Kamal. So what we learn from this, higher magnitude of force applied, then the direction of the force also, follows the magnitude there. Okay, boleh ya. Tadi dua-dua sama, so car dah move. Now Kamal got more force, so it will move towards Kamal. Okay, next, number 3. Okay, this one got some trick there. Careful with this, guys. See, the compression balance is already showing you 0.1 Newton. Okay, then they ask you this, based on the diagram above, determine the reading of the compression balance after object M is immersed in water. Okay, initially object M outside there is 0.76 Newton. Okay, once you put inside water, the amount of water displaced, okay, so becomes now, that means the water displaced is here. That means the Newton reading, the spring balance reading shows 0.54. Okay, let's try this. Okay, so 0.76. Okay, the initial spring balance reading minus 0.54, you will get 0.22 Newton. Okay, then but initially guys, get 0.22 Newton is not the answer. You must plus 0.1 Newton. You know why? That is the weight of the container, the beaker that is already there. So the spring balance already show you 0.1 Newton initially. So the total here plus this, then you get 0.32 Newton. Jadi baru jawapan dia. Jadi soalan 3A. Answer. Okay, get why this tambahan right there is because the spring balance is already showing you 0.1 Newton. Where did the 0.1 Newton come from? The 0.1 Newton is the beaker that is present on the spring balance there. So you must include that as well. So then only you know what the reading, final reading will be there. Okay, so it is 0.1 plus this lah. This is actually the what you call the mass of the object there, because this is the amount of water displaced is 0.22 Newton. 0.76 minus 0.54 will be 0.22 Newton. Okay, next, name the force that enables object M to float. Object M to float. Okay, 3, 1, 2. Okay, name a force that enables object M to float will be buoyancy force of water. Buoyancy force lah. Then state the relation between the force in 3B2 and the weight of water displaced. The upthrust, amount of water going up, equals to water displaced. Okay, the upthrust there, that is the rock that is placed inside that generates upthrust that is equal to the water that is displaced there. Okay, this is all. If I just explain like this a little bit more, when you come back, I'll show you a little bit of experiments and everything there as well, like guys. Okay, boleh ya. For now, upthrust is equal to the water displaced there. Next question is also a very good question, makes you think. Hot question. You see a boat overloaded. Okay, shows a boat that is overloaded. Describe what will happen if the number of passengers is increased. Already overloaded, some more you're going to tambah passengers means the boat will sink. Why? The weight of the boat is higher than the maximum upthrust and is unable to displace water. Okay, so there's no more upthrust there. That means the boat now starts to go in and you cannot displace the water. When you cannot displace the water, what will happen is the boat will start to sink. Okay, the boat will start to sink there. The terminology, what is upthrust there, what is the maximum thrust that is available, what is water displaced, what is water displaced dan sebagainya. Please go back to the previous worksheets, check a little bit guys. Okay, check a little bit, then answer all this properly. Okay, check the answers. Okay, check the answers properly, do it properly. Okay, then next question is already another part related to pressure. State two factors that affect the pressure. Okay, will be surface area and force and surface area guys. So what is the formula for pressure is force over surface area. Okay, pressure is force over surface area. Okay, force over surface area. Then next, that means what guys? Same force, smaller surface area. Let's say both the force is 50 newtons. 50 newtons to objects. But smaller surface area, larger surface area. Which one got more pressure? Which one got more pressure? This one got 50 Newton meters. This one will have only 25 Newton meters. So smaller surface area, pressure will be more. Larger force, more pressure. Smaller surface area, more pressure. Okay. Any parts you still got doubts, you're still not sure. Maybe just like questions, all these questions. Go back the last two lessons and check back all this. What is pressure, what is force, all this were explained previously. Okay, next, explain the purpose of the action. See what he did here. The following diagram shows chains put on a car tire, driven on snowy icy roads. So we won't face it here in Malaysia, like guys, snowy icy roads. Yeah. So explain the purpose of the action. Okay, when you do that, you put chains around it. What happens is you actually decrease the surface area. You shrink the surface area of the tire. But the surface area, the whole tire, there is a surface area. Now you put the threads there, you put the chain around it there. The chain becomes the surface area of the tire. So what happens is surface area kurang. When surface area kurang, what happens? The pressure increases. More pressure. More pressure means what? Got more grip. That means got more pushing. The tire is pushing onto the surface of the road. So it gives it more grip there. Okay, so the change of the tire shrink the surface area. You put chain, you shrink the surface area. Surface area kurang. Surface area less equals to more pressure. Surface area less, pressure more. Okay, so there is more grip. This will increase the pressure and grip of the tire on the icy surface. Pressure and grip on the tire will increase on the icy surface. So the car is more stable, the car won't skid off from the icy surface. Okay, hopefully this helps you, gives you a little bit of an idea there, guys. I'll send you this copy of the answers as well. Okay, as usual, you always get the answers for each worksheet, this one also, but I want you to go through, this time do it properly. You're already finishing this chapter. A little bit of the level part I will do, a little bit before I move to the next chapter. But if not, you're actually done with the chapter. Okay, next, Peiji wants to cut some fruits, but she feels difficult as the knife is blunt. Blunt knife means what, guys? Larger surface. So what you must do, logically you must already make it sharper. Sharper means smaller surface. Sharper knife, smaller surface. Smaller surface means more pressure. Smaller surface means more pressure. That's why like running time, and I think why in stadiums dan sebagainya people use the running track, why people use spikes. Spikes give you more grip. So when you're running really sprinting fast, you don't slip off the track, you don't fall off dan sebagainya. Why people use football boots? Football boots, there's smaller surface area. Smaller surface area gives you more grip. So you can run, you can kick with one leg, and one leg there can grip onto the ground. You will not fall off that. Okay, smaller surface area, more pressure. So what must do? Sharpen the knife lah. You sharpen the knife, this will decrease the surface area. When it decreases the surface area, increases the pressure. So when you got more pressure on the knife, cutting becomes more easy then. You don't have to put a lot of force, the same force. Peiji uses the same force. Peiji uses the same force there. But because now got smaller surface area, easier to cut the fruit then. Okay, next, number 5. This one, what can force do? Force can change direction, force can change shape, force can change speed. Okay, so what can force do to an object there? That one also step by step I explain one by one, give you examples there. So like example, let's say a shuttlecock comes, you can place the shuttlecock in another place. That means you're changing the direction. Let's say someone passes you a football there, you kick harder, that means what you do? The speed, the motion of the ball there, you can increase the motion of the ball there as well. Okay, you're a goalkeeper, ball comes, you can stop a moving object there. Okay, so what force can do? But this one also teach you, only give you 2 pictures, guys. First one there, someone crumpling something. Someone crumpling, can't see the pictures here so clearly, guys, but someone is crumpling something. Crumpling means you're changing the shape of an object. Can be plastic, can be paper, you crumple there, you change the shape of an object there. Number 2 is the person with the baseball bat and the ball is there. So what is happening is changing the direction of an object. Direction I accept. One more thing is speed of an object also I accept. Because yes, ball can come in slowly, when you hit there, you can actually give it more speed there. But you can increase the speed of the object there, one, or the direction of the object. Dua boleh pakai untuk soalan 5A2. Okay. Next, Mr. Rama is a farmer. He moves his crop by carrying them in a big plastic bag. One day, his friend advised him to use a wheelbarrow as shown in the diagram. What class of level? Class of level is what we've done. Okay, but this is actually second class level. Second class level. Number 1, guys. Okay, this is one part. I'll keep first. I'll explain to you all the 3 classes of level: first class level, second class level, and third class level. I'll explain to you. Now we discuss this part here first. So the one only have one answer for that part, which is second class level. Let's come to this, guys. Look at this here. Formula already given. Sorry guys, delete this for me. Okay, erase for me. Now look at this here. Load times distance from load.